In this lesson, we shall focus on mathematics, MATH141 calculus, a UKZN module. We shall look at integration, focusing on integrals that run up to infinity in terms of limits of integration. This one stretches from, for example, minus infinity to exactly infinity, right? So we'll have a perfect opportunity to discuss these particular questions and make sure that we understand exactly what is happening and we move forward, right, by trying the next questions. We'll remember that we spent some time looking at these particular questions like this particular one, and we're able to do that last time. So we're trying to look at the kinds of questions we did not spend time on. We looked at this one, we looked at this one, we looked at this one. Okay. We looked at this one, we looked at that one. Okay, yeah. In particular, here it's this particular one, the E. We looked at it, and we solved it. And we also looked at 2F as well, this one. We solved 2F. Okay, and so we looked at 2F, this one. Okay, and then we had 3A. We had 3A. We looked at 3A. We looked at question 4. And then we looked at 6A, yeah? And then we need to look at B right now. We did not look at B. But maybe we can look at A again. Should we look at A again to recap and then look at B and spend time on the partial fractions just to create an environment in which, we can be on the same page. I feel that it's a brilliant idea. So we're going to look at this particular question again, 6A. And then we shall look at several questions on partial fractions to make sure that you're a bit more confident on the partial fractions. Right. And I'm glad that you're trying some questions on the partial fractions earlier today afternoon. Right. First and foremost, to look at this particular question, we shall actually have to write. This one is A over x plus 1. B over x plus 1 squared. Plus C over x plus 1 cubed. Plus 3. You cross multiply, which is A. If you cross multiply the x cubed with this, is going to be x plus 1 squared. B, you cross multiply this and that. You have x plus 1, and then you have C that way. Which means there's 2x squared, there's 7x plus 3. You multiply out here, and if you square these, it becomes exactly x squared plus 2x plus 1 plus b. You can write already here bx plus b plus c, which is 7x plus 3, x squared, 2ax plus a, bx plus b plus c. Meaning we have exactly 2x squared plus 7x plus 3 x. Okay. Okay, the x squared is only one quadratic term, so you can only write exactly the ax squared. And then you have exactly twice a plus b. So that in the end, okay, so that in the end, then you have the following. It is therefore clear that at this point, a equals 2. 2a plus b equals 7. But if a is 2, then it becomes 2 plus b equals 7. And then equals 3. So that now you have 3. A is 2, B is 3, C is 3. C is minus 2. So that we have 2x squared, 7x plus 3, all over x plus 1 cubed. A is 2. A is 2 over x plus 1. B is 3 over x plus 1 all squared. C is negative 2. Right, so you can put exactly negative 2 over the cube. Now, the couple of things you need to take into account and check, if you add these, do we get that back? That sort of becomes the question. So to check this, before we proceed, you'd have to take the lowest common denominator, which is x plus 1. You cube it, and you divide x plus 1 cubed by x plus 1. You have the square. Okay. So you have that. So you have 3, and then you divide this one by that. And then minus 2. So that now we have 2x squared plus 4x plus 1, 3x plus 3 minus 2, which is 1. Two x squared. And then you add the 4x and the 3x. You have 7x plus. Okay, let me see. And then the 1 and the 1 would give us what? Would give us exactly. So yeah, this one is a 2. Okay, if you distribute it, it's going to be a 2 plus 1, giving us a 3. Yeah. Divided by x plus 1, you cube it. Yeah, just a warm up this one. Just a warm up exercise. So that obviously, I mean, this can be broken down to these partial fractions. Okay, so you have this. Okay, we have the integral of 2 over x plus 1. Dx, and then you have minus the integral of 2 over x plus 1 cubed like that dx. So this becomes the derivative of this one is 1, and therefore this becomes the ln of that. So we have that, and then now you integrate this one using the same law that when you integrate u to the minus 3 du, for example, it's going to be 1 over minus 3 plus 1 u to the minus 3 plus 1 plus c, and therefore this is minus 1/2 u to the minus that plus c. So it's sort of the same law. And you'd have therefore minus 2 over, and then you have minus 2 so that in the end we have 2 the ln of x plus 1 minus 3 over x plus 1 plus, if you divide you get a plus, and it's 1 over x plus 1, you square that plus c, and therefore this becomes the answer to the question 6a. Well, once again, just a recap on that one, it's just a warm-up exercise, but also an opportunity to think about what we need to do in relation to partial fractions. We shall spend a bit more time on partial fractions, just doing a couple of more problems to make sure that we are on the same page when it comes to partial fractions, and we can actually make sense of these kinds of questions, but also we can be able to apply our understanding of the concepts of partial fractions in attempting to understand this section very well. One of the most interesting sections, but also very, very applicable. So you have a perfect chance to learn this particular problem, and we actually move forward. We look at the next question. Right. So the next question here is exactly what? 5x squared. Three x minus 2 divided by x cubed plus 2x squared. So that now you have x plus 2. Right, so what would this one be, for instance, for the x squared? You would expect that it would be a over x, b over x squared, c over x plus 2. Okay? Pause to reason about this one here upon careful examination, but also you have perfect chance to reason this out and make sure you understand this. So, okay. So now, yeah, pay particular attention to that. So you get exactly this particular problem here. Okay. This is what we have. But now, then we will simplify this. You multiply it through by the LCD, getting 5x squared, 3x minus 2 equals a. Multiplying by the LCD would give us ax. Okay, the LCD being this one, you multiply by the x squared, in brackets, x plus 2, so you get x plus 2. Multiply this one and this one. You multiply this one and this one. X squared, 3x minus 2, which is ax squared, 2ax, bx plus 2b, cx squared. Right, you have a plus c right now, and you have the x squared terms, then the linear terms in x, which is this. So that in the end, then you have twice b. Okay, twice b is equal to -2. This means that b equals -1 upon division by what? Upon division by 2, both left and right. Next, we have twice a plus b. It is equal to 3. Okay, because you're comparing the coefficient of x, 2a plus b, with the 3. And then now the b is -1. So that b is 5. A plus c is 5. So that in the end, okay, there's a small thing here. Here I mean that you need to have, okay, the 2a plus b coefficient of x on the left must be equal to 3. Two a is 4. A is 2. Okay, then you have a plus c. Okay, a plus c is 5. But you already have that a is 2. So c is 3. This -1, and a is what? A is 2. Hence, what we have here is that 2x squared so that in the end, with a out of x, b out of x squared, c out of, okay, this is not what I actually, I mean, I'm thinking about this one. 5x squared, 3x minus 2 divided by x cubed plus 2x squared. Right, which is exactly that. Okay, because obviously, I mean, this is justified by the denominator factorization. So you'd have the for example, that you have this one, 3x minus 2, then you divide by x squared, which is x plus 2, a over x, b over x squared, c over x plus 2. And 2 over x squared, 3 over x plus 2. That's the integral. 5x squared with 3x minus 2. 2x squared. The integral of the... So to do this integral, then you'll have to do the integral of 2 over x. Dx, which is 2 the ln of this. If you integrate this one, is plus 1 over x. Plus 3 the ln of x plus 2. Plus c. Okay, look at this one and make sure you understand it. In the presence of a question, please, you can ask. But this would be the integral of this particular question in B. This would be the integral in part B of this particular question here. And yeah, very clear. Let C as a constant, as the arbitrary constant of integration. But now we're going to move to the next one. Moving to the next one, we're going to solve the next question on the partial fraction decomposition technique. Okay, with that, we solved B. Let us do this one. Right, so we're going to do 6c, for instance. 5x squared with cx plus 2. Which is x plus 2 plus 5. Which is a over x plus 2. Bx plus c over x squared plus 2x plus 5. Okay, so because this one, the x squared plus 2x plus 5 can be written like this. But also, this one here is irreducible. The x squared, this x squared, the x squared plus is irreducible. So that in the end, then you multiply out by the LCD, if this is irreducible, because if you look at the discriminant of it is b squared minus 4ac. You want to determine the factors. The A is 1, the B is 2, the C is 5. A, that 4 minus 20. You have 2 squared is 4 minus 20, which is minus 16. Negative, and obviously you would have non-real roots. You would have non-real roots. By dint of that, it means you have this one, 6x plus 2. You cross multiply, which is exactly x squared plus 2x plus 5. Okay, and then we have x plus 2. So that then in the end, you have 5x squared. Okay, yeah. So you'd come to distribution, which is exactly x squared, 2ax, 5a plus. You come to this one, which is bx and x is bx squared, 2bx, cx, 2c, giving us 5x squared, 6x plus 2. With this one here plus 2b. Okay, and then you'd have like what extra term? So we have these, and that. So that in the end, then we have 5a. And then 2c. Check these carefully. I don't want us to make mistakes. 5x squared and that, they give us the a plus b with the x squared term. 2a, 2b, c. And then we have 5a in that. So now we have 5x squared a plus bx squared plus 2b. Two b plus c. And then we have 5a plus 2c. So a plus b equals 5. So if a plus b equals 5, that corresponds to a plus b equals 5 corresponds to the coefficients of the quadratic terms. 2a twice b plus c is equal to 6. 5a plus 2c equals 2. Okay. 3 equations and 3 unknowns. We need to find the values of a, b, and c. Six x plus 2 okay, plus 2x plus 5. Okay, let's check this one. Let's do a quick check. So what we're going to do now is to look at these particular expressions. Okay, so we need to look at A plus B so okay, we have 5 here. 2, 2, 1, 6, 2, 2. So that then in the end we have 1, 1, 0. 2, 2, 1, 6. 5, 0, 2, 2. 1, 1, 0, 5. Row 3 minus 5, row 1. 0, 0, 1. So you have 0, 0, 2. Minus 5 times 5 is minus 25. With the 2 is minus 23. Like that. Okay. Take a look at this and see if we can get some solution here. It appears that there's no unique solution to this. Okay, that's very interesting. I'll have to check this out. I'll have to check this out and see what's happening here. And see what exactly is happening here. Right. Okay, I need to check this out. Okay. Yeah. Let's just check again. So you have the A plus B, 2A plus 2B plus C equals 6. 5A plus 2C equals 2. So that now we have 115, 2216, 502 equals 2, and 1105 minus 10. Okay, yeah, the mistake is here. Okay, because you multiply row 1 by -5, you add to this, you get a 0. Multiply by -5, you add to this, you get a -5 here. Multiply by -5, and you add here, you get a 2. Multiply by -5. Right? You get a minus 25. Multiply by -5, you get a minus 25. You add to 2. Becomes a minus 23. Okay, take a look at that one. Okay, we're using matrices here. Now at this point, you can switch these two rows and bring this row to the bottom. Row 3 and 2. Zero, zero, one. All right, and then you need to get, and then here you have 0 minus 5, 2 minus 23. Okay, and then you continue with the matrix reduction process. At this point, you want to obtain a 0 here. So the way to do that would be to multiply by minus 1/5 row 2. 1, 1, 0, 5. 0, 1 minus 2 out of 5. 23 out of 5. 0, 0, 1 minus 4. And then now you continue with the row reduction process. Check writing this matrix on the next board. So we have, for example, 1, 1, 0, 5. 0, 1 minus 2. 23 out of 5. 0, 0, 1. Okay. At this point, you want to get a 0 here. Row 1 minus row 2. 1, 0, 2 out of 5. Row 1 minus row 2. 5 minus this is check. 5 minus 23 out of 5. 25 minus 23 out of 5. 2 out of 5. And then this one is 0. 1 minus 2 out of 5. 23 out of 5. We have the following as we continue with the reduction process. You have here row 1, row 1 minus 2 out of 5, row 3. And then now you have row 1 minus 2 out of 5, row 3. So the row 1 is 2 out of 5 minus row 3 plus 8 out of 5, which is 10 out of 5, 2. Yeah. Okay, now we're going to do row 2. Plus this one, row 3. 0, 1, 0. So row 2. Okay, this one is 23 out of 5. Okay, so you have row 2. And then plus 2/5 row 3. So row 2 is this one. And then you have 2/5 row 3 come to this one here, which is minus 8/5. So this one, if you subtract, we have 15/5, giving us exactly 3, 0, 0, 1, 94. Okay, with this mentioned, it means therefore you have the following, right? So it means that A is 2, B is 3, C is -4. Yeah. So A is 2, B is 3, and C is -4. Right. And with this mentioned, so if A is 2, so we've got that A is 2, B is 3, and C is -4. Thus, we have 5x squared, 6x plus 2, you divide by x plus 2 plus 5. And this is a over x plus 2, bx plus c over x squared with 2x plus 5. A being 2 over x plus 2, b being exactly 3 minus 4 divided by x squared, 2x plus 5. Okay, and this means hence we're able to achieve the following and be able to find the integral of this. The integral of 5x squared, 6x plus 2 divided by x plus 2, x squared plus 2x plus 5. So you have the integral of this dx. We have this divided by x squared plus 2x plus 5. Two x. Okay. Now, when you get to this point, you need to integrate this one. But now to integrate this one, the derivative of these is 1. There's a formula that says that if you have f of x whose derivative is in the numerator, the integral becomes the ln of f of x, ln of the modulus of f of x plus c. Right now, but what is the derivative of this? Now, you can show that derivative of these is related to that. So by the derivative of the x squared, it becomes 2x plus 2. Yeah? And so you're able to see, therefore, that it's not exactly that. So you need to perform some extra algebraic simplification as follows. So you then say, if you have exactly this one, 5x squared with 6x plus 2, you divide by x plus 2 together with x squared plus 2x plus 5. Dx becomes the integral of 2 of x plus 2. Dx. The integral of 3x minus 4 divided by Okay, yeah, there's a dx here. Two x plus 5 dx. But look, what exactly is this? So from this, you would need that if you find the derivative of this, it becomes exactly 2x plus 2. The derivative of this is 2x plus 2. So you'd need a 2x here. Right, you'd need a 2x there. Meaning that if possible, you need to factor out in a way that is going to allow us. So if you factor out a 3, factor out a 3 and multiply it by 2 simultaneously. So you factor out a 3, and then you multiply it by 2. Moving towards the margin, you have this one, x plus 2 dx. Factor out 3, multiplied by 2. With that mentioned, factor out 3, it's going to be exactly 2x. And then at this point, you factor out 3, and then you simultaneously multiply by 2. Right, if factor out 3 is going to be minus 4 out of 3, multiplied by 2, it becomes minus 8 out of 3 like that. So that's what you get. Minus 8 out of 3. You divide by x squared double x plus 5. So we have this. Now, you want a plus 2 to come out of this. You want a plus 2 to come out of that. And to get a plus 2 coming out of this, you need the integral. Plus 3 out of 2. 2x. 2x plus 2. Okay, then you have 2x plus 2. But you see, if you have 2x plus 2, then what should be added? This is how you can reason it out. You can say you're going to add, you have minus 8 out of 3. You add something, call it y. Right, so in other words, in the place of minus 8 out of 3, you added 2, and you're wondering exactly what must be in this space there. Let me actually do that carefully so you can say you have 2 plus a y, it must be minus 8 out of 3. Okay? 2 plus something. 2 plus something is minus 8 out of 3. What is it? This would mean y is equal to minus 8 out of 3 minus 2. Minus 6 minus 14 out of 3. So you have minus 14 out of 3. Okay, so that's what you have. And then it's x squared 2x plus 5. Dx. Okay. Right, so take a look at these and reason. So in the end, then you have exactly this. So you therefore have the integral 6x plus 2. X plus 2. X squared plus 2x plus 5. Which is the integral x plus 2. And then you have the plus 3 out of 2. Okay, because the 3 out of 2 that you're seeing here is going to be 3 out of 2, but you're going to have the 2x plus 2 with the dx. So you're going to have 2x plus 2 dx over this. And then now you have 3 out of 2 with minus 14 out of 3. The integral 3 out of 2 minus 14 out of 3. 1 over x squared plus 2x plus 5 dx. Okay, and we have exactly this. We have exactly this. Giving us 2 out of x plus 2 dx. 3 out of 2, the integral. 2x plus 2, x squared, 2x plus 5. Okay, the 3 cancels, and this gives us minus 7. 1 divided by x squared plus 2x plus 5. So that in the end, now you come to exactly this one. Now, completing the square. X squared 2x plus 5. X squared plus 2x plus 2 out of 2. Half the coefficient of 2 of x. Minus the same, you add 5. X plus 1, you square it. So yeah, and then it's going to be exactly this here. This is 5 minus 1, giving us a 4. And this takes us back to the arctangent, 2 over x plus 2 dx, 3 out of 2. The integral of 2x plus 2 divided by x squared plus 2x plus 5 dx minus 7. The integral of, now when you come to this one, it's 1 over x plus 1 squared plus 4 dx. So we have this. And then we are just obviously almost getting the answer, and we have the following to do. We still have the integral. We still have the integral of 5x squared with 6x together with 2 x plus 2, x squared plus 2x plus 5 dx. So we have the following. So that here we have the integral 2 over x plus 2 dx 3 over 2 2x plus 2 dx minus 7 1 over plus 4. Okay, then what you need to do here to integrate this one, you need to let the x plus 1 okay, you must let this thing be 10. But you must make this the square root of 4. And then you put 10 theta. And therefore, it's the same as saying x plus 1 is 2 10 theta. To the second squared of theta d theta. Like that. Okay. Meaning we have actually the integral of 2 over x plus 2 dx. 3 over 2 to x plus 2. X squared plus 2x plus 5. Minus 7. Right, and at this point in the denominator, you're going to have what? You're going to have exactly wherever there is x plus 1, you're going to put 2 10 theta. And then you square that. We have the 4. What is dx? Dx is 2 secant squared. 2 secant squared theta d theta. 2 out of x plus 2 dx. 3 out of 2, the integral of 2x plus 2 x squared plus 2x plus 5 dx. 2 sec squared. 2 sec squared theta d theta. So it becomes 4 10 squared theta plus 4. So the 4, you pull it out. Okay, you can pull the 4 out, and then obviously we have the 10 squared. We continue with the integration process of the 5x squared. 6 squared plus 6x plus 2. X plus 2, x squared plus 2x plus 5 dx. It's 2 over x plus 2 dx plus 3 over 2. The integral of 2x plus 2 which is x squared plus 2x plus 5 minus 7 the integral of x squared theta d theta. So we have the integral of 2 divided by plus 3 out of 2, the integral of 2x plus 5, all divided by x squared plus 2x plus 5 dx. Now the 14 out of 4 is 7 out of 2. Sec squared theta d theta. Which is 2 divided by x plus 2. Which is x squared plus 2x plus 5. And then this one here is exactly what? It's exactly d theta because the secant squared over secant squared is 1. Let us perform the integration all at once. This gives us 2 the ln of x plus 2. 3 over 2 the ln. Okay, this one it's a 2x plus 2. It's a 2x plus 2, 2x plus 2. So even here it's going to be a 2x plus 2. 2x plus 2. Yeah, so yeah, if you find derivative of this, it becomes 2x plus 2. So that's the ln of 2x plus 2. If you let u be this. And then minus 7 out of 2 theta plus c. Okay, what is the answer to this? It is 2 the ln of x plus 2 plus 3 out of 2. 3 out of 2 the ln of 2x plus 2 minus 7 out of 2. And you can write it up. You can write the final answer up here. So in other words, this is what we are able to achieve. Proceeding from here, it's 2 the ln x plus 2 2x plus 2 theta. And you'd remember that we said that x plus 1, we said let x plus 1 be 2 tan theta. And this means that theta itself is going to be x over 2 arctan. Arctan of x plus 1 excuse out of 2. Check this out. Check this out. Okay, so we'll be able to get minus 7 out of 2 in that. So we'd have Let's see now. Yes, so this one is octane. Okay, we have this. We have exactly this. So, oops. Okay, here I meant that is the ln of the denominator. Okay, so here it becomes the ln of the denominator. So it becomes the ln of x squared to x plus 5. X squared to x plus 5. Okay. So, okay, look at these and think very carefully, but that'll be the answer to the question 6C. That'll be the answer to the question in 6C. Right, in which case, therefore, the next one to do is question D. Okay, we're trying to spend a bit more time on partial fractions just to, create that general pattern of reasoning. By dint of what we've said now, it means, therefore, that we can say hence the integral of 5x squared divided by x plus 2, x squared plus 2x plus 5. And then it is exactly with this, plus 3 out of 2, the ln of the modulus of x squared plus 2x plus 5 minus 7 out of 2, the arctangent of x plus 1 out of 2 plus c. Okay, check this out. Okay, now let's look at part D. Now, to look at part D, you need to look at the partial fraction decomposition of x squared minus x plus 2 divided by x cubed minus 1. It's x squared minus x plus 2 all divided by, okay, if you have x cubed minus 1, it is x cubed minus 1 cubed. Difference of 2 cubes? Well, difference of 2 cubes in the sense of grade 10. So you'd have x minus y, x squared, xy, y squared. Which is x squared, x plus 1. Which is x minus 1, x squared, x plus 1. So you have exactly this. We have exactly this. Right, so now we can be able to use the partial fraction decomposition as A over x minus 1, and then we have bx plus c over x squared plus x plus 1. Right, so we need to deal with this, and so what exactly do we do here? And also, I mean, you can ask the question, is the numerator, can it be simplified this? X squared minus x plus 2, can it be written as x minus 1, which appears in the denominator? Or what are the factors of this? X plus 2, okay, so you can see that it is no real factors. Okay, so okay, now when we're here, you multiply through by the LCD, getting exactly x squared minus x plus 2, which is a over x squared plus x plus 1, bx plus c over x squared minus 1, minus x plus 2, which is ax squared, ax plus a, bx squared minus bx plus cx minus c. A plus b a minus b plus c plus a minus c. X squared minus x plus 2. X squared minus x plus 2 is a plus b times x squared plus a minus b plus c plus a minus c. Getting a plus b equals 1. A minus b plus c equals negative 1. A minus c equals 2. So we continue with this. Now, at this point, you'd have to form matrices from these three equations. Getting 1, 1 from here, 0, 1. 1 minus 1, 1 minus 1. 1, 0 minus 1, 2. Row 2 minus row 1. Row 3 minus row 1. Right, we need row 2 minus row 1. Row 3 minus row 1. Okay, so at this point, you'd have to interchange rows 2 and 3. One, 1, 0. 0 minus 1, 1. Minus 1, root 2. One, 0, minus 1, 2. If you add row 1 and row 2, you add 0 plus 1, you get a 1. You add these two, 1 minus 1. You add minus 1 and 0, you get minus 1. You add 1, 1, you get a 2. And simultaneously, the third row remains unchanged. Moving forward, it's going to be row 3 plus 2, row 2. 0, multiply this row 2 by 2 and you add. It's going to be 0 multiplied by 2, you add, you get a 3. Multiply by 2 and you add, you get a minus 4. Okay, and therefore this is going to be exactly be minus 4/3. In the D part, it's going to be exactly minus 4 out of 3. Okay, so we check this out. Make sure we commit no mistakes here. Right, make sure you commit no mistakes. Right, so we get exactly x squared minus x. I'm just checking something here, plus 2. And then you have x cubed minus 1. Okay, at this point, you need to which is 1, 0, minus 1. 0, 1, 1. 0, 0, 3. 2 minus 1 minus 4. 1/3 row 3. 0, 1, 1. So that you have row 2 minus row 3. Row 1 plus row 3. 1, 0, 0. You add these two, so if you add 2 with minus 4 out of 3, you get 6 minus 4 out of 3, and the result is 2 out of 3. So here you're going to have 2/3. Right, to add, you have row 2 minus row 3, you have a 0, 1, 0. Which is 1 out of 3. Okay, we get that. We need to check if this is correct. This is correct, and therefore this means that our A is 2/3, B is 1/3, C is minus 4/3. So that then if you are actually supposed to perform this integral here, but before that, it means x squared minus x plus 2 divided by x cubed minus 1 is can be seen as a over x minus 1 bx plus c over x squared plus x plus 1. So it's a over x minus 1. So it's a over x minus 1 bx plus c over x squared plus x plus 1. And so our A is 2/3. Right. So whatever we're able to get here is that our A is 2/3 over x minus 1. Minus 4/3 over x squared plus x plus 1. So that then the integral whenever I have the integral of x squared minus x plus 2 divided by x cubed minus 1 dx, okay, which is this one here, is equal to the integral of 2/3 over x minus 1 dx plus 1/3 x minus 4/3 over x squared plus x plus 1 dx. Starting from the margin, 2/3 can be pulled out over x minus 1 dx. 1/3 the integral of x minus 4 so that now you get exactly this. Okay, this one is going to be very easy to integrate, but we have to deal with this one. So you'd have the x minus 1, but you need to deal with this one here. And so to deal with that one, we proceed as follows. Right. So we continue. We continue. And so at this point, we obtain the following. We obtain the following. So the derivative of the denominator, x squared plus x, would just be 2x plus 1. So we want to get a 2x plus 1 here. So we want this x to become 2x. And for that, so you need to multiply by 2 here and also divide by 2. So you have a 2 out of 6. So multiply by 2 and divide by 2. 2/3 the integral. 1 over x minus 1 dx. You multiply by 2 and divide by 2, so it becomes 1/6. You multiply by 2, it becomes 2x minus 8. X plus 1. Okay, now this one, you want it to be 2/3. 1 over x plus 1. Which is exactly x squared plus x plus 1 dx. So here you need a minus 9. Because if you say 2x plus 1 minus 9 like this, then you can have 1 minus 9 is minus 8. So yeah, you have minus 9, which is x squared dx. So you have the integral of x squared minus x plus 1 over dx. To get the following. Okay, let's check. So you'd come to the integral of this one here is 2/3 the integral of 1 over x plus 1. Yeah, just to change this one to 2/3 1 over x plus 1 dx. Check this out. Okay, and then we continue with this one, 1/6 2x plus 1 integral. X squared x plus 1 dx minus 1/6 9 over x squared plus x plus 1 dx. Okay, by completing the square here in the denominator, x squared plus x plus 1 can be written as x squared plus x, the half the coefficient of x, which is 1, minus the same thing, continue, So this one is 1 minus 1/4, because if you square the half, you get 1/4. So if you say minus 1/4 plus 1, the 1 is like 4 to 4. 1 out of 4, which is 1 out of 4, like this. That's 1 minus 1/4. I mean, you get 3/4. So you get 3/4. So from 1, you remove 1/4, then you must get 3/4. Right, so here you get exactly 3 out of 4. Okay, we continue. So I need to deal with this. So now you'd have exactly 2/3. The integral of 1 over x plus 1 the integral of 2x plus 1 divided by x squared plus x plus 1. 906, the integral of 1 over x plus 1/2 squared plus 3 out of 4. Okay, these two can be easily integrated, but we need to integrate this one here. Right, and to integrate that one, we proceed as follows. We need to be in a position to find the integral of the last one. In other words, to compute this integral here, so we're doing the integral of x squared minus x plus 2. Divided by minus 1 dx. Two-thirds 1 over x plus 1. Why is it x plus 1? It must be x minus 1. So this is x minus 1. X minus 1 from the x cubed, so it must be minus 1. You can see that it had changed to a plus, but it's a minus. It's a minus. It's a minus. Dx. So you have this. Yeah, okay, we're back. And then now it is 1 over x minus 1 for this one, and then 1/6. 1/6 of the 2x plus 1. Over x squared plus x. Okay, now the minus 9 out of 6 is the same as minus 3 out of 2. Right, that's minus 3 out of 2, the integral of that. One over. So you need to let x plus 1/2 be the square root of 3 out of 4, the tangent of theta. This means that x plus 1/2 is the square root of 3 out of 2 tan theta. This means that dx square root of 3 out of 2 sec squared theta. So that at this point, you have 2/3 of the integral of 1 over x minus 1 dx. 1/6 of the integral of 2x plus 1 over x squared plus x plus 1 dx. Minus 3 out of 2. So that you have this one here, the tangent of theta, but you square this, plus 3 out of 4. The dx becomes the square root of 3 out of 2 the secant squared, d theta. Okay. So this is 2/3 the integral of the x minus 1 dx, 1/6 dx. So now you would, okay, so you'd have that, and then this one here, we have that exactly, okay. So this one is going to be 3 out of 4. Yeah, so you have 3 out of 2 here, and then you have the square root of 3 out of 2 from the numerator, and this one is 3 out of 4, giving us 4/3. Sec squared over sec squared is 1. Okay, the 10 squared plus 1 is going to be sec squared. So it's going to be exactly d theta. This is 2 times 2, which is a 4. 4 is going to cancel. The 3 is going to cancel. 4 is going to cancel. 3 is going to cancel, giving us the square root of 3. Right. 2 times 2 is a 4. And then there's 4. Just going to cancel, and then you'd have the square root of 3. Right. In other words, whenever we have the integral of x squared minus x plus 2, all divided by the x cubed minus 1 dx. What is this integral here? It is 2/3 Okay, let's remove this one. So we'll be getting exactly 2/3. The integral of 1 over x minus 1 dx. Plus 1/6, the integral. 2x plus 1 over dx minus, okay, the 2 times 2 is 4, it cancels, and the 3 cancels, leaving us with minus the square root of 3. Minus the square root of 3. Okay, let's check now. Minus square root of 3, and then you have the integral of the d theta, which is actually exactly a theta plus c. And this is 2/3 the ln of x minus 1, 1/6 of the ln, because the derivative of this is the same as the numerator, it's the ln of the denominator. Minus square root of 3 theta. Remember, everything came out of the denominator, and the denominator became, it was x plus 1/2 cos the square root of 3 out of 2, 10 theta. So want to make theta the subject, to multiply through by the 2, by these 2 here, so that it becomes 2x plus 1 is the square root of 3, 10 theta. You divide by the square root of 3. You have the 2x plus 1 over the square root of 3. So that in the end, 2x plus 1 over the square root of 3 equals theta. So that this is the square root of 3 arc 10. 2x plus 1 over the square root of 3. Okay. So let us check this out. So it's 2/3 the ln of x minus 1 plus 1/6 the ln of x squared plus x plus 1 minus square root of 3 octan of that. I think that is some good time for us to take a break. What do you think? Or let's continue and take one more problem. Let's do E. Let us do E. Right, in doing E, we'd have the following. Right, so we're going to try E. So I have the integral of this, but now let us do the partial fraction first. So you'd have the 4x cubed. But now look at the degrees. This one is degree 3. The denominator is x squared, degree 4. Meaning that, obviously, you need to just straight away proceed with the partial fraction decomposition technique. So you have this one. You divide everything. And then you have x squared plus 3. Okay, we continue. So ax plus b divided by x squared plus 1. cx plus d over x squared plus 3. Which means that you have 4x cubed minus 5x squared plus 10x minus 7. Right. Okay, we continue. We continue. So now, if you multiply it through by the denominator, this one here, you're going to have ax plus b which is x squared plus 1. Okay. So you need to just expand this one. Get ax cubed 3ax b x squared 3b. Dx cubed dx squared which means I have a plus c Okay, yeah, a plus c for the cubic terms to make sure don't make mistakes here. And then now you'd have the other terms like the quadratics. Quadratics will be b and d. For this, linear terms, 3a and c, x, and then the constant terms, 3b and d, like so. Right. Okay, we continue. See, upon careful examination, you're able to analyze this. But what we're getting here is that 4x cubed, 5x squared, a plus c cubed, your b plus dx squared, and then 3a plus c x, and then 3b plus d. You actually are able to see that a plus c now is 4. b plus d is a negative 5 for the quadratic coefficients. 3a plus c is 10. And then you have 3b plus d equals the constant minus 7. Okay, so it's easy to see that A plus C is 4. 3A plus C is 10. Subtract this by saying 3A minus A by subtraction. So 3A minus A would give us 2A, and C minus C is 0. 10 minus 4 is a 6. Dividing by 2 means A is 3. This one is B plus D. B plus D is -5. You subtract this one by saying 3B minus B is twice B, D minus D is 0. And then if you say -7 minus 5 gives you a -2. Dividing both sides by the 2 gives us B is -1. With A plus C equals 4. Which means that A is 3. Which means that C is equal to 1. And then if B is -1 in the place of D, B is equal to -1 with B plus D. B is -1. Plus D is -5. D is -4. Okay. So now you're going to have exactly that. Check this out. Right, let's check this out. Continue. Right. Okay, let's continue. So if the integral of 4x cubed minus 5x squared, 10x minus 7, all divided by x squared plus 1, x squared plus 3 dx. So we can see that you remember that we started with this and we had ax plus b and then cx plus d. Right, we can even remove the integral sign for now. And then remember that this was equal to ax plus b over x squared plus 1. Cx plus d over x squared plus 3. What is the a? The a is 3 and the b is -1. 3 and -1, giving us 3x minus 1 over x squared plus 1. C and the d, 1 and -4 over x squared plus 1. Okay, I mean, First things first, it's very important to always check if these answers are correct. Very important to have an idea of the fact that this partial fraction decomposition is actually very, very correct, because, there's always a chance of human error here. And so now if you actually can be in a position to get these, then you would have the most important things to do here. +1 +3 right. So let's think about this a little bit and just check if the partial fraction decomposition is correct. Okay, we're just dealing with the integration of partial fractions. So now you'd have the 3x minus 1, the x minus 4. I must indicate that it is correct. I just check that this decomposition is correct, and therefore you can perform the integral. So that when you actually can doing the integral of 4x cubed minus 5x squared, 10x minus 7, x squared plus 1, x squared plus 3 dx. It is 3x minus 1 over x squared plus 1 dx. The integral of x minus 4 over x squared plus 1 dx. Okay. So now you have to do this particular integration. To do this particular integration, we shall proceed as follows. Now I'm going to do it on the next slide because it's nice, easy, and short. So to find the integral of 4x cubed minus 5x squared, 10x minus 7 over, all over, x squared plus 1, x squared plus 3. Which is 3x okay, which is x minus 4 over x squared plus 1 dx. Which is the integral of 3x over x squared plus 1 dx, 1 over x squared plus 1 dx, the integral of x over x squared plus 1 dx, 1 over x squared plus 1 dx. Okay, now the derivative of this x squared becomes 2x. So you'd have this one, you want it to be 2, so you'd have 3 out of 2. 2x over x squared plus 1 dx. Now the integral of this one is octan. So let's leave it for now. This one, derivative of this one is 2x, so you'd have to introduce a 2x plus 1 dx the integral of 1 over x squared plus 1 dx. Taking it to the top here. 3 over 2. The integral of these, therefore, if you differentiate these, you get 2x, and therefore it becomes the ln of the denominator, x squared plus 1. That is for the e integral. Continue with the integration process. Come to this one. Right. Come to this one, and then that is the part E. And then now the integral of this one, it's the minus arctan of x. Which is the ln of x squared plus 1 minus 4 arctan of x plus c. Okay, this is small typo here, check. This is x squared plus 1, this one is plus 3. See what I did here. Let me see. Okay, this one is 3. I'm wondering why I made it that, because it must be 3. X squared plus 1, x squared plus 3. Check that. So it must be a plus 3. Okay, so this is a plus 3. Check it out. So this is going to be a plus 3. Okay, it's going to be a plus 3, plus 3. Okay. So it's going to create a small change here. Or at least some change in the answer. Now, I would want us to zoom into the kind of the integral you'd get here. Okay, it will be just for this part, for the last part. Okay, let us check for the other first few parts. It's going to be very, very easy. Like for this one here. In the part E, this one is going to be 3 out of 2. X squared plus 1. Minus, this one is arctan of x plus, this one is the derivative of this, so it's 1/2 the ln of x squared plus 3. Okay, 3 over 2 the ln of that, 1/2 the ln of that, minus that one, that, and we just need to get this one. So to get this one, we'd have to let x be the square root of 3 tan theta. Sec squared theta d theta. which is 310 squared. Dx square root of 3 sec squared theta d theta. Meaning you have square root of 3 out of 3 sec squared, and the 10 squared plus 1 is going to be sec squared, and this gives us only d theta. And you have to find the integral of d theta, which is okay, 1 over the square root of 3 out of 3 is going to be 1 over the square root of 3. Making this one here, it's going to be like 1 over the square root of 3. And this is going to be theta plus c. But this gives us 1 over the square root of 3. The theta is arctan of x over the square root of 3. Let's see, but we have the minus 4 here, which is going to be minus 4 square root of 3 arctan of x over the square root of 3 plus c. Okay, so check that, but this is the answer anyway. And then we are having one last question on the partial fractions, and then we move to other things. Let us spend some time to look at this particular question. But first and foremost, we look at the fact that the degree of the numerator is 4 and the degree of the denominator is a 3, meaning that we can perform long division. Okay, so let us manipulate this. So you have 4x to the 4th cubed minus 22x minus 10. Four x squared plus 4x minus 8. You divide this one by 2x cubed, then you get only x. Is it 2x? Multiply this one by the 2x cubed, you get actually exactly 2x. Multiply this by that. 2 times 2 is a 4x cubed times x is x to the 4th power. This times that, it's minus 8x cubed plus 8x squared minus 16x. And then when you subtract, you get a 0 there. And then this one and the negative there, it's going to be a plus, getting us actually exactly 4x cubed, negative this, which is minus x squared. This and this, 6 minus 6x minus 10. Okay, take a look at these and make sure that we get the correct thing. Moreover, now this is what we have, and then we perform further division. We have this one divided by the 2x cubed. You get exactly a 2. Multiply this, which is 4x cubed minus 8x squared plus 8x minus 16. Okay, this one, you add this and it becomes 9. Becomes 7x squared. And then this one is minus 14x, and then this one is plus a 6. Right. Okay, let us pause to make sure that this particular division is correct and is division that does not have any sort of mistakes in it. So with 4x to the 4th power minus 4x cubed plus 7x squared minus 22x minus 10, 2x cubed minus 4x squared plus 4x. Okay, I'm just trying to check that there's no error here in any way, because this is very important for us. All right. Let us check this out. Let us check this out. It looks very, very correct. And therefore, now it means that we can write the following. We can be able to write that 4x to the 4th power. Okay, so can be able to write that 4x to the 4th power, this one, minus 4x cubed plus 7x squared minus 22x minus 10 divided by 2x cubed minus 4x squared. It is the quotient. The quotient is, so if you divide, you get the quotient and then remainder this. Remainder this one. So this one is the remainder. Right. 7x squared minus 14x plus 6 divided by 2x cubed for x minus 8. All right. Now you have this. But now at this point, you need to perform further algebraic manipulations. Yeah. And if you do that, you'll be able to obtain the following. To start with, the 2x cubed minus 4x squared plus 4x so this is going to be minus 4x squared plus 4x minus 8, which is a 2x, giving us exactly x squared minus 2x. Let's see. Okay, let's take out 2x squared and see what happens. Yeah. So if you take out 2x squared, take out 2x squared. Take out 2x squared. So you have minus 4 here, which is x minus 2. X minus 2 is a common factor. Pulling out x minus 2 would leave us with 2x squared minus 4. And then you have the x minus 2. Okay, with the 2 outside from the second set of brackets, with 2, x minus 2, and then you're going to have x squared minus 2. And then these can be seen as x minus 2. Right. Then you can perform the further factorization as it can be seen clearly. In other words, what we're getting here is 2x plus 2. Then we have 7x squared minus 14x plus 6 over 2x minus 2. Right, and then out of this, you can write x minus the square root of 2, and then you can write x plus the square root of 2. Right, and then when you get to this particular point, you can be able to write this out with so much ease. In other words, whenever we have 4x to the 4th power minus 4x cubed, 7x squared minus 22x minus 10, all divided by 2x cubed minus 4x squared, 4x minus that. So now, plus. Okay, at this point, then you have this. The 7x squared. The 7x squared minus 14x plus 6. Which is 2 into x minus 2. X minus the square root of 2, and then x plus the square root of 2. So this would be a over 2x minus 2 plus b over x minus the square root of 2 c over x plus the square root of 2. Like this. Multiplying through by the LCD, and the LCD is this, which is the same as that. You'll be able to get 4x to the 4th power minus 4x cubed, 7x squared, 22x minus 10. Okay. Multiply through by the LCD, and then you're going to have exactly this part here. Let me see what the best way to do this is. Okay, the best way to do this is to focus on the partial fraction decomposition of this. Right, so meaning that you can just focus on this one and you multiply it through by the LCD so that we have 7x squared minus 14x plus 6. Yeah, in other words, you focus on this one. Focus on this. But also you focus on this, only this. Okay, now, if you deal with this, then you multiply by the LCD. It's going to be A into, okay, you multiply, so this x minus 2 with the 2 is going to cancel, then you're going to be left with this and that, which is x squared minus 2 plus b. You would have 2x minus 2 okay, so x minus 2 and then x minus the square root of 2. Just exactly this way. Now, this one is an interesting one. I'm going to use a different method to solve because of the availability of the square root. If x is 2. If x is 2, this one is going to be 0. That is going to be 0. If x is 2, you're going to put 2 here. 2 squared minus 14 times 2 plus 6. Okay, if x is 2, then you put it here. It's going to be 2 squared minus 2. Then the rest are going to be 0, but the meaning is after that 2 squared minus 2 gives us exactly, it's like 4 minus 2, giving us 2a. Okay, so this one, 7 times 2 squared, which is 7 times 4, giving us exactly 28 minus 28. 28 minus 28, because 14 by 2 is also 28, which is 0. This gives us exactly 2a is equal to 6. A is 3. A gives us exactly 3. A gives us exactly 3. So now you're going to also do the other one when x equals the square root of 2. So we're going to do it maybe in this place here. If x is, let's first do the square root of 2. If you put the square root of 2 here, this one is going to be 0. If you put the square root of 2 here, you square the square root of 2, it's going to be 2 minus 2, it's going to be 0. If you put the square root of 2 here, this one is going to be 2 the square root of 2 plus 2 the square root times 2 the square root of 2 is going to be 4 the square root of 2. Right, so it's going to be 4. 2 the square root of 2, 4 the square root of 2, 2 the square root of 2, 4 the square root of 2. So 4 the square root of 2b so that we have 7. You square the square root of 2 becomes 2 minus 14 the square root of 2 plus 6. Okay, take a look at that. So we're getting 4 to the square root of 2, the square root of 2 minus 2b. And then it is minus 14 to the square root of 2. Then we have 14 plus 7 by 2 is 14 plus 6, which is what? 20. Right. And at this point, you have b is equal to, you can divide through, getting minus 14 to the square root of 2 plus 20 divided by 4 to the square root of 2 square root of 2 minus 2. Think about it, but we are going on. We are going on. Okay, we are going on. Right, we are going on and on and on and on. Let me see what we got here. I think that there must be a small error. Let me see. Uh-huh. Okay, there must be a small error. Let me see. I'm trying to check over the divisor. What are the factors of the divisor? Okay, I'm trying to see if there's no mistake here. Okay, just 1 second. So you have 2x cubed. Right, so you have 2x cubed minus 4x squared. Plus 4x minus 8. Okay, see, this is more error. Let me see if I can detect that error here. So if you come here, you pull out 2x squared. You have x minus 2, and you pull out, this must be plus. See, there's a mistake. So this would have to be a plus. Pulled out just 4. And therefore, you come to this point. It's going to make the work a bit less because we're writing too much now. So you come to this point, and this one is going to be plus here. When you pull out the ER, it's going to be plus. Two x squared plus 4. Oh. So now, okay, pull out the 2 here, giving us exactly x squared plus 2. X squared plus 2, so we are. So it's going to make a couple of changes for us. In particular, right, in particular, because of that sign rectification, so this is going to be much simpler than ever. Okay. So now what we then have is the following. So we're going to have exactly this. So that in the end, then you're going to have this plus, in the denominator, we have 7x squared minus 14x plus 6. 7x squared minus 14x plus 6, all divided by the 2 into x minus 2. And then you have x squared plus 2. Okay. Meaning you have this one, and then you continue with the partial fraction decompositions. It's going to be a over 2x minus 2. Then you add bx plus c over x squared plus 2. Like we said, so we're going to deal with this one. And also simultaneously deal with this one here. So that now you have exactly 7x squared minus 14x plus 6, which is equal to, so you multiply by the LCD, so it's going to be exactly, if you multiply by the LCD, which is this, you multiply this, so the 2 into x minus 2 is going to cancel, leaving us with a multiplied by x squared plus 2. Bx plus c, so you multiply by the LCD, which is this, which is yeah, this is going to have cancel. So this one is, if you multiply by this LCD with this, the x squared minus 2 is going to cancel, leaving us with 2x minus 2, like that. Okay. So now, the couple of things that remain very important here for us to take into account, but we can be able to get with 3 of this. So if x is 2, then you can get 1 of this, you can get a. Then we can vary the others. But simultaneously, you can try to do this as 7x squared minus 14x plus 6, which is this one, plus 2a plus. So this one is going to be like 2x times bx, 2bx squared. So bx times 2x, 2bx squared. Bx times minus 2, minus 4bx. Plus 2cx. Yeah. Minus 4, which is minus 4c. Okay. But then in the end, okay, we get this, giving us 7x squared minus 14x plus 6, which is a plus 2b x squared. Okay, then these two will cancel out. Two c minus 4b. And then okay, so now you would have to find the right coefficients. At this point, it means that A together with twice B must be 7. Also, minus 4B twice C is minus 14. 2A minus 4C is 6. Okay. All right. So if we can take X to be 2, then this will be 0, and that is going to give us the value of A. And then you can get the B and the C. That's one way to do it. So we can say, for example, if X is 2, put it here. So this is going to disappear, and if X is 2, then it's going to be A with the 2 squared plus 2 is equal to 7, 2 squared minus 14 times 2 plus 6. That's what we got earlier. Okay, but now this is going to be plus, so it's 2 squared, so it's a 4 plus 2, it gives us a 6A. Where are you? Now, this one is 28 minus 28, giving us 6, which means that A is 1. All right. Okay, think with me, please. Okay, if A is 1, then we come here. With A together with 2B equals 7. A is 1. 1 plus 2B is 7. 2B is 6. B is 3. Once you get that B is 3, you need to get a C. Can you use this one? Can use 2A minus 4C is 6. 2. A is what? A is 1. The C we don't know, and this is the case, which means 4C is 2 minus 6. This will bring C is a minus 1. Okay, now let's reason. Okay. Now we are back here, and I want us to look at these very carefully. So what we have here now is, I want to just make sure that there are no errors here before we proceed. So I'm trying to pause to reason and make sure that we do not have any mistakes before we move on, because it's going to affect the integrity of our solution. So it's very important that everything is clean so that we are on point, but also we do not waste our time moving forward with mistakes in our calculations. Two x cubed. Four x squared. 4x. Okay, we get these exactly. Okay, let's reason this out. You see, what we're able to achieve out of this is the fact that whenever we have 4, everything here, this one, whenever we have 4x to the 4th power minus 4x cubed, 7x squared, which is 2x cubed plus 4x minus 8. Okay, then it's what? It is 2x plus 2 . Okay, and then now you have the A here. What is the A? The A is 1. So it's 1 over 2. 1 over 2x minus 2. The B is 3 and the C is minus 1. So it's 3x minus 1. Divided by x squared plus 2. Okay? Now we are in business and we want to just get the integral of this. So the integral of 4x to the 4th power minus 4x cubed, 7x squared, 22x minus 10, all divided by 2x cubed minus 4x squared plus 4x minus 8. Two x plus 2. The integral of 1 over okay. Okay, so in the end, this one can easily integrate. This one can easily integrate. The issue is here. So let us start from the margin a little bit and write a little bit more. So we'd have the integral of 2x plus 2 dx, which is 1 over x minus 2. Three over 2. 2x over x squared plus 2. Okay, because then if you differentiate this, you get that back. But these two cancels, giving us the 3x minus the integral of 1 over x squared plus 2 dx. Integrating this, we are done. What we then need to do is find the integral of the 2x squared. So the integral of the 2x squared is just going to be x squared. The integral of 2 is going to be 2x. This one is going to be the ln of x minus 2. Three over 2, the ln of the denominator, x squared plus 2. This one does pause to reason this out, but to reason this out, we need to find the integral of this. So, okay, to find the integral of this, let me just extract the integral so that anybody can follow what we're doing here. So we actually need to find the integral of 1 over x squared plus 2 dx. We let x be the square root of 2 tan theta. Dx square root of 2 sec squared theta d theta. Like this. So that when you get this, you'd come and then this integral. So in the denominator, if you square the x, you square this one. It's just going to become 2 tan squared plus 2. And the derivative becomes the square root of 2 sec squared theta d theta. And then the 2 is pulled out, which is 1 over the square root of 2. The sec squared over sec squared becomes 1 theta d theta. And the integral of this becomes 1 over square root of 2 theta plus c. And the theta out of this becomes x over the square root of 2 arctan. So that becomes arctan of x over the square root of 2 plus c. But obviously you are dealing with this. You are dealing with this. Right, you are dealing with this. Dealing with this, then you have 1 over the square root of 2 outside. Arctan of x over the square root of 2 plus c. Plus c. Like that. And this is the answer. Right, in other words, we are then saying this integral in f is this here, it runs up to there, it goes up to there, it goes right through there, up to the C, and then. Okay, like that. So that is the integral of the f part. Okay, good. Thank you. Thank you so much for joining us. I think it was awesome having this discussion, and we actually can practice with more things, with exactly more things, more integration by parts, methods that we can learn. Any questions so far? Any question? Right. Thank you so much for joining us. It was awesome having this discussion. Until next time, thank you. Take care and goodbye.